Now you know what is lattice enthalpy. That is, energy is released when two atoms which are in the ionic form, they combine. That is your lattice enthalpy. Now students, let's discuss what are the factors that affects this lattice enthalpy. Now let's see our first factor. Now we can say that, as you can see on the screen, force of attraction, correct? So we can say that more is the force of attraction between the anion and cation, higher will be the lattice energy. Now what do you mean by this sentence? Suppose you have an example of sodium chloride, correct? Your sodium is positively charged, your chlorine is negatively charged. So similarly, when two opposite ions, let it be sodium or potassium, when two opposite ions, they combine together, that is your lattice enthalpy. But the charge on this ion, so more is the charge, that is, when the positive or negative charge is more, then the energy or lattice enthalpy will be more. Why so? Because obviously if the force of attraction, that means if charges are more, that means they are coming together and attracting to each other by more power, we can say that, correct? So hence this is your first factor. We can say that more is the force of attraction between two ions, that is your cations and anions, then more is your lattice enthalpy, correct? Similarly, that was your lattice enthalpy first factor. Now similarly, if higher the charge on the ion, more will be the force of attraction, no doubt in this sentence. If the charge on the ion is higher, for example, if you have Na plus and Ca2 plus, correct? So if we consider sodium plus and calcium 2 plus, correct, the charge on calcium 2 plus is more, so attraction from calcium 2 plus will be more. So it is very easy, we can say that the more or the higher the charge on the ion, more will be the force of attraction. So what does it means? That means it has higher lattice enthalpy. Is this clear? Very clear, no doubt in this. Let's move ahead. So we can say that now from this, from what we have discussed, we can infer that your lattice energy, correct, or lattice enthalpy is directly proportional to the charges. That is, now what are your charges given? That is your Z plus, which is denoted as positive charge, and your Z minus, which is denoted as your negative charge. So we can say that if the lattice energy is more, the charges will be more, or if the charges are high, that means your lattice energy or lattice enthalpy will be high, and your charges are Z plus and Z minus, which are your cation or anion respectively. Now let's move ahead. So from this, for example, let's take an example now. If we have sodium fluoride, okay, you can see on your screens, you have sodium fluoride, you have MgF2 and you have AlF3. Now if you have to give the order of enthalpy, according to our discussion, we have just discussed that order of enthalpy or lattice enthalpy is directly proportional to the charges. We have just now discussed. Now let's look at the example. We have what? We have sodium fluoride. So sodium fluoride dissociate as what? Na plus, correct, and F minus. Similarly, you have MgF2. How does MgF2 dissociates? Mg2 plus 2F minus, correct? And similarly, we have AlF3. Now, how does AlF3 dissociates? It dissociates as Al plus 3 plus 3F minus. I hope you know this. There is any doubt in this? There shouldn't be any doubt, as you know the charges. Your sodium possesses plus charge, your magnesium possesses plus 2 charge, your aluminium possesses plus 3 charge. Now what is common in them? Your fluorine is common. So we can say that anion is common with negative charge. But if you compare the cation, now what is your cation in the first case? That is Na plus. In the second case, it is Mg2 plus. And in the third case, it is Al plus 3. So you tell me students, which will be the highest enthalpy showing? Obviously, as just now we have discussed, higher the charge, more will be the lattice enthalpy. So Al, your aluminium, has plus 3 charge, so it has maximum lattice enthalpy, which is followed by your magnesium, which has 2 plus charge, and then comes the least, that is your sodium, because your sodium contains only single positive charge, whereas your magnesium contains 2 plus and aluminium contains plus 3. So your order is clear. I hope this is very easy. There is no doubt in this. Let's move ahead now. So now let's take another example. Now suppose let's talk about oxides of alkali and alkaline earth metals. What are alkali and alkaline earth metals? You know group 1 and group 2 of periodic table. Those are your alkali and alkaline earth metals, correct? So now take example of sodium oxide, that is Na2O. Then you have magnesium oxide, that is MgO. And then you have aluminum oxide, that is Al2O3. Again, simple step you will follow. First you have to dissociate your ion. So how it will dissociate? Let's take the first example, Na2O, correct? How does Na2O dissociates? Na2O dissociates as 2Na plus plus O2 minus, correct? And how does MgO dissociates? MgO dissociates as Mg2 plus plus O2 minus, correct? Now similarly you have Al2O3. How does Al2O3 dissociates? It dissociates as Al plus 3 plus O2 minus. Now again students, if you look at your screen, all has same anion and the same charge on anion, that is O2 minus, correct? So now again check the differences. Now again your charge on cation is different. If you look at sodium, it is sodium plus, magnesium 2 plus, aluminium plus 3. So again the same concept of charge. More is the charge, more is the lattice enthalpy, correct? So now it is very easy and clear that your aluminium plus 3 will have the highest enthalpy. So now we can say that you have Na2O, which is least, then followed by MgO, which is second, and which is followed by the highest enthalpy due to the maximum charge is your Al2O3. I hope this is clear. So remember, always charges is very important. More is the charge, more is the lattice enthalpy, and such question can come into exam to arrange your molecules or atoms according to the increasing or decreasing order of lattice enthalpy. I hope this is clear. Now let's move ahead.